And get started. So at Nubank, we've scaled from a small startup to 100 million people, 100 million customers. And we've done this by focusing on one key principle: it's simplicity. I'm not sure how many attendees here work at Nubank. If so, then some of this will be review for you. And again, I appreciate your patience. This is intended to be recorded and shared, publicly elsewhere. Yep. Um, and so, yeah, we are, if you have familiarity with the origin story of Nubank, or if you have familiarity with the origin story of Rich Hickey and Clojure and Datomic, maybe this will be review, but hopefully it will be fun at least. Okay. So how many of you have experimented with those IoT, like smart home automation systems? Because myself, you can look around me. I'm very creative. I'm very environment driven. And so, and I hate the big lights. I hate the big lights. We need to have aesthetic lighting. And so when the smart systems came out a few years ago, I totally fell down the rabbit hole. I wanted to automate everything so it would be super easy. I started out by getting a Google Home microphone, and then I got, the cheapest little LED smart lights I could find from Costco. And of course, these lights came with their really horrible little vendor app that was so bad. So I decided, okay, I'm going to manage everything through the Google Home app. And at first, it was amazing because I'm already a programmer. I just took all of my daily routines and I turned them into automation scripts. And I had all the lights in my house come on at sunrise, and they turned to like a cool daylight, bright white. And then the afternoon, they dimmed. And then, like, right before sundown, it's time to set the mood. And then they all turned to like these groovy rainbow colors. And this still happens to this day. And in the morning, I had a wake up routine. It would read me motivational affirmations and start playing music. And this was all great for like a week. And about a week into this, I then discovered that the authentication from the vendor apps that was connected with Google would just expire without warning. And then none of my stuff would work because it couldn't authenticate into that other lighting system, that lighting app. So I'm like, all right, well, I'll just sysadmin it. And I redid everything in the crappy vendor app. So then it didn't have to authenticate through Google Home, had all my lights and schedules still on that schedule. Eventually, everything's going well. I added a smart thermostat to my home system, and I'm like, oh, the energy saving is going to be amazing. And I had a friend do this, and they installed an Amazon Alexa smart thermostat, which is a direct competitor to my Google Home system. So now I couldn't control my thermostat in this other systems, and I couldn't manage it with my wake up routines and my bedtime routines as I was intended. And another problem I started to experience with these systems is my inability to share my access with my friends and my family, because I created the system. I knew how to use it, but they didn't. And so I would have friends crash on my couch, and they would awaken at sunrise to bright white light right in their face. And they would do the natural thing and unplug the lamp to try and get some sleep. But unfortunately, this would reset all of those lights, and I would have to spend another hour resetting them and renaming them and redoing everything I did. And eventually it hit me that I had taken something so simple, a light switch, an alarm clock, a thermostat, and I made it so complex that it stopped working for me, and it started working against me. And next thing you know, this was my life, is, just always, and I still manage these systems, and I don't know how to do it. It's gotten even worse. So that's exactly what happens in software development too. When we add these layers of abstraction and dependencies and automation, we think it's going to make things easier until the complexity leaks and gets in the way. And just like my smart home system, we eventually end up spending more time debugging the system than actually benefiting and using it. So today we're going to talk about software design. And when we're talking about software design, we're really talking about the interaction between humans and technology. And the success of a system depends on how well it serves both. And then there are three levels, kind of three levels of scale at which complexity will manifest. We have the operational scale, and that's the choices that we made, or organizational scale, I'm sorry. These are the choices that we make at this large company-wide level. And we're asking questions like, how do we ensure that teams can collaborate effectively and that systems remain flexible and that we can keep our agility at this bigger scale? And then we go, a little bit smaller scale, and we think about our team and how complexity affects engineers who are working together on a team on a project. And we think about things like, how can we maintain a shared understanding, common language, clear interfaces, and a sustainable development process for a team. And then at the end of the scale is the individual. And we want to think about how an engineer experiences complexity in their day-to-day work, and think about how we build systems that are easy for an individual to reason about, an individual to debug and extend. And sometimes these individuals are different individuals. And so throughout this talk, I'm going to keep coming back to kind of these themes of human versus system, and then these three levels of scale. And we're going to examine how simplicity can be an asset and a superpower at each level. But first, let's back up a little bit and let's consider Nubank and why they cared. So Nubank was founded to challenge traditional banking and create a better financial experience for customers. Traditional banks have a ton of complexity and barriers of entry, especially in Brazil, to my understanding. And, it costs a lot of money to build a very secure brick and mortar building. And then you need to pay employees and you need to pay security and you need to keep money. And all of this gets very expensive. And then those costs get passed down to the customer. And that's reflected in their user experience because it's really hard to do anything like even just get your own money. And then banks are less willing to give things like loans because they have bigger risks. Because what if they can't pay their bank teller? So the founders of Nubank had a different vision, and they wanted to avoid these costs, and they wanted to operate more like a technology company, and they wanted to make things like credit lines more accessible to the general population. They wanted to help people share money with each other. And, they had big dreams. And so they needed to do that. They would have to do things really different. And if they were going against these, big banking institutions, they really couldn't afford risk. And if they wanted to empower their employees to act like owners, not renters, that's one of our values, they needed to create an environment where they inspire their developers with confidence, the confidence that's necessary for learning, because it's really hard to learn if you're so fearful that every time you make a mistake, you might mess with somebody's money. That's terrifying. And so they sat down. You think the saying is they didn't know about hammocks yet, but they sat down in a chair and they considered what tools they wanted to use. And they came across Datomic. And Datomic is an immutable database that was unlike anything they'd seen before. And so I remember back in 2019, there was a conference called the Clojure Conj, and I distinctly remember Nubank's sponsorship presence at that conj. I think Edward may have given a talk at that one. If not, it was years before. And I remember Nubank really kind of stuck out against all of the other colors because they were like cool and like obviously the whole brand just resonates with my whole everything. I loved that. Um, and so the Conj, as it's known, is the original conference for Clojure people. And so Clojure is an open source Lisp inspired JVM based programming language and has a super loyal community. Um, it was, managed by Cognitect, is the consulting company that employs most of employs most of the Clojure core team at that time. And even though Clojure was open source, they created Datomic, and Datomic, that database, is kind of Clojure's like ideological extension or like spiritual successor, and it's a free to use database product. And so, the Datomic team and the Cognitect team, they've always been super highly regarded for their keen Socratic inspired thinking skills. And they're known to be very loyal to their principles. We're going to talk about some of those today. So kind of at this bigger level, we have Cognitect. And then, I think the community at large, also at events that Cognitect will sponsor. And then we had the Datomic and the Clojure core team. A lot of them were employed at Cognitect. And then we have Rich Hickey, who is the creator of Clojure, the talker of good talks. We will reference him a lot. And like I said, if you know this stuff, thank you for bearing with me. So Clojure and Datomic. Remember how I said we were very principled? They were built on these core principles of focus, power, and simplicity. Today, we're focusing on simplicity and why it was a strategic advantage and how it's shaped our engineering culture and our culture at Nubank in general. So this is a little Datomic symbol to recognize that. So the second line in this abstract for this description for this talk, I said, by designing systems that are easy to understand, extend, and maintain, we have avoided the common pitfalls of growing software teams and infrastructure. But let's define, I actually made an oopsie because simplicity and something being simple and something being easy, we should not conflate those two things. Now we want systems that are simple and easy, but just because something is easy does not mean that it's simple. And oftentimes, the easier something is, the less simple it is. So let's talk about what simplicity means and what easy to understand means and why should we care. So when Rich did a talk, he has made a crucial distinction between simple and easy. Simple is simple. It means it's just one thing. Something being simple is objective. Anyone can see that the thing is simple because it means one thing. It's not relative. It's not easy. Easy can be relative. It can be something that's easy for me can be difficult for you. But something that is simple is always going to be simple. So keeping things simple for humans is about reducing our cognitive load. Because as humans, actually the number is 7 plus or minus 2, is a number that we can manage thinking about at one time. That's an important number in teaching. So when teachers teach, they really can't effectively teach more than 7 things in a lesson because our human brains cannot deal with it. That is also why phone numbers are the length that they are, because past a certain amount of digits, humans cannot memorize it. So if we consider that, keeping things simple is about reducing our cognitive loads and staying as low, being able to focus on the least amount of things as possible. So the opposite of that is when you create complexity by combining and interleaving things and intertwining and creating dependencies. So you make it so, like, when you think of one thing, you have to consider 3 other things. And that's what we want to try to avoid doing. So systems that get complex and unruly become nearly impossible for engineers to reason about. I'm sure you've been on a team where we just say, you know what, it works, don't touch it. And, oftentimes, if even the author of the system, due to the complexity and due to all the interleavings and all the dependencies, if they get lost focusing on what's important and what's relevant and what isn't, if the senior engineers who wrote the thing can't even get focus in the system, then other teammates who are newer to the team or just less experienced, they have no chance. And so my first few years as a software developer, I spent a lot of my time hunting down bugs in kind of React-based Clojure script stacks. And it would be for hours. I'd be tracing user interactions and their side effects, trying to figure out where the undesired behavior came from and why this person doing this mouse click caused this seemingly unrelated thing over here. I blamed the pesky mutable state that was coming from the appdb. But one of the tools that Clojure has is the REPL, and the REPL became my best friend because my only saving grace was being able to check the state at every turn, at every event, at everything, and observe the state at different points. And as the user interaction went on before it went to the server, I was able to see what the data was, and that was my saving grace. So simplicity isn't about what's convenient. It's about thinking really carefully about and creating things that are objectively purposeful and objectively succinct. It's about reducing interleaving, minimizing dependencies, and ensuring clarity for both humans and your technology system. When you keep things simple, you enable better communication and collaboration for humans because you're able to focus on one thing at a time. When you reduce humans' cognitive load, you enable them to make clearer mental models. And when you have a clearer mental model, you're able to find the flaw in it a lot easier. And we want to reduce the cognitive load to enable us to focus and find what the real problem is, because that's important. And then for technology systems, when we keep things simple, we get very reliable, predictable behavior. It means we have fewer dependencies, fewer of those side effects to trace down the line. And as a result, you get a higher reliability. So, so then we talked about these 3 levels of the organizational, team, and individual. Let's think about what it means to keep it simple and easy at the organizational level. At Nubank, what we do is because we've gone all in on Clojure, we use similar tools. So Clojure and Clojure script. Clojure is based on the JVM and it compiles to Java. Clojure script is slightly different tooling, but is the same syntax. And so a back-end team and a front-end team can actually communicate and write the same syntax and proof the logic in each other's work. That's really valuable. And then Datomic is just the database version of the language, of those languages. And so it makes it, it enables us to be very flexible with, as an organization. And you're able to make lateral movements. You're not, if you know, you're doing some back end work and you really want to move to front end, that's actually possible. And that's nice. It also means keeping it simple at an organizational level means that we're united in our goals and our values. As I said earlier, one of our values is we act like owners, not renters. And that means, you know, taking initiative. That means feeling trusted to make good decisions. And when something's wrong, we can just fix it. And we don't need to ask for permission to fix it. That's pretty important. So next at this team level, what does it mean to keep it simple at a team level? Well, we communicate as teams very frequently. There is a design principle that was popularized by Rich. It's in a talk called Design in Practice, and it is a thinking framework. And we tend to, before, you know, I can't speak for all engineers because, of course, some people don't feel the same way. But we've noticed that teams that collaborate frequently in all of their thinking processes before they start writing individual code, you know, they develop familiarity with each other's thinking patterns and familiarity with the code base through shared analysis and shared design thinking and peer review. And this familiarity is part of the definition of making something easy. And so, you know, we keep things simple by, you know, thinking about things before we code up a complex thing. And then we make it easy by creating familiarity through communication. And then at this last level, we have, you know, what's it look like to keep it simple at the individual level? Well, it means putting aside your ego. And I know it's hard, right? But, you know, we are not our ideas. You know, I have bad ideas all of the time. And I love that. I love being wrong. It's such a it's such a freeing thing to be wrong and to know that my ideas are not my identity. And so as an individual, if you are able to you know, put aside your ego and know what your level is, and then create the communication with your team to put yourself in this. There's an area called the zone of proximal development, and that's where effective learning happens. It's where you are taking your previous experience and you're extending it just a little bit, and that's where learning happens. And so, you know, what that means is asking for help frequently, asking for feedback, um, being willing to put, you know, instead of just thinking you have the solution and wanting to win or be the hero, you know, think about it, consider you could be wrong, and engage with other people about it before you go off on a solo mission. And that's hard to do. You know, it can be fun to do solo missions. Um, but that's what keeping it simple and easy um, means. So, all right, we're going to move on to this next section here of problems. So we are obsessed, the Datomic team. We are obsessed with good problem statements. We're always talking about problem statements, good problems to have. Um, but what does that mean? So, Rich delivered an internal talk at Nubank called The Problems with Problems. I wasn't able to find any of these talks. I'm excited to share this because I wasn't able to find a copy of this talk externally. And so this is actually copy pasted one of his slides. He opens with problem solving is an art and a skill. And just like any skill, if you practice, you get better at it. And there are actual techniques. It's like when you, once I started writing documentation, I got so into looking up documentation, right? I used to just, I would get IKEA furniture and be like, I'll figure it out. It's fine. No, no, oh, nay, nay, not anymore. Now that since becoming an engineer and writing a lot of documentation myself, I think it's so wonderful that somebody that has proficiency has sat down and written all of the techniques and practices that you should do to understand what you're doing. Um, so yeah, to get better at something, we want to practice it. And he advocates for problem-oriented project management. Let's think about this human level. What do problems mean at this human level? And it means managing projects from a place of problems. And problems aren't bad. We have this idea that problems don't have to be negative. Um, we want to we keep things simple with problem-oriented project management. And it prevents us from writing features just for the fun of it. Even when you're writing a feature, you should start with a problem statement. What is the problem that the end user customer is experiencing? And then assume that you're wrong. And again, get that feedback and talk about it with your team. But when we approach things from this problem-oriented mindset, um, we don't create things just for the sake of creating things, because the more interdependent things that there are, the greater the complexity, and that doesn't scale. We also are a big fan of using spreadsheets for something called decision matrices. Um, I have a hard time making any decisions without a spreadsheet anymore. My friends make fun of me so much for my obsession with spreadsheets, because it's such a structured way to make a decision based on clear criteria. Um, I suggest, if this is interesting to you, you can look into that Rich's talk, Design and Practice. So going back to good problems to have. I watched this talk. I'm just going to kind of summarize some parts for you. So he explored the word origin of problem, and it comes from the Greek meaning something put forward or thrown before. So he also elaborates that problems are not just one thing. Problems are somewhat recursive. And there's kind of like three key interpretations, right? We have a good problem, or good problem statement really, is an obstacle to overcome, questions that you need to answer, and then tasks that you need to accomplish. And they come with that's in the format of a specific problem statement that has explicit criteria. So problems are not inherently negative. They're actually super essential to progress, both in life and in business and personal and in systems and human and in organization, human and in technology. And engineering and software development inherently deal with unknowns. And anytime you have an unknown, that requires a structured approach to problem solving to reach an objective conclusion on what you should do. So before jumping to solutions, we feel like it's critical to identify the real problem. We want to repeatedly ask why. And that goes into the Socratic method that we're fans of. And then we want to engage with the scientific method when the causes are unclear. So why? If we don't know why, well, let's write a hypothesis and experiment about it and see if we're right or not. I once heard the scientific method described as I don't know if I'm allowed to curse. Uh, frick around, I guess. Frick around, find out, write it down. Easy, right? Or simple, I should say. So problems are also rarely, we want to avoid thinking about problems as a puzzle with like one specific solution, because problems require exploration and multiple possible solutions before implementation. You need to think about your implementation steps, think about all of your solutions and what the cause and effect. Really, when you're looking at your decision matrices and you're trying to decide what the problem is and how to move forward on it, something you are judging it on is its complexity. We have these 3 different implementation strategies for solving this problem, and we want to analyze based on, does this solution create other things that we will have to maintain? Does this solution, create a dependency on this other part of the system that we may not always control? Um, that's the kind of things that we want to think about. So there's this structured approach to problem solving that involves documenting the problem statements and the root cause analysis and thinking of lots of different solutions before implementation. As you're thinking about your obstacles, you're thinking about the solutions and what questions you want to answer with your solutions, using explicit criteria. And problem solving the goal of problem solving should be to reduce your complexity and avoid late realizations. You want to completely think something through before implementing, because it's the worst. We've all made that mistake when you think you're doing something right and the unintended consequence blows up. That's no fun. So this is kind of just, problem solving in our theories, our philosophies, our principles. So, going to applying this more to programming in Nubank. In Rich's talk, Effective Programs, 10 Years of Clojure, he identified all of these problems are the problems he feels in programming, right? And then the problems that are taken on by Clojure are the ones that are highlighted in green here. And then what we'll discuss right now is, the Clojure took on all these ones in green, and then Nubank, the problems that are relevant to Nubank and banking systems in Brazil. Let's discuss that at an organizational level. Misalignment across teams due to diverging tech stacks or decision-making silos creates this like weak support for information. At this team level, we'll oftentimes have a hard time onboarding new developers due to an overly complex system or lack of documentation. And that has to do with language model complexity. And at an individual level, developers struggling with this cognitive overload that we discussed before from excessive state management as a result of place-oriented programming and mutable data structures. Place-oriented programming is the opposite of something Rich advocates as a value-oriented programming. And I will recommend some resources to dig into that. But it basically is a consequence of mutable state, that when you're when you're trying to change something and you go into the place and you actually change the place instead of making a copy and changing it in this other, changing the value over here, that's the difference. And we see a lot of consequences from place-oriented programming, because that's really what object-oriented programming is based around. And that mutable state creates a lot of bugs, a lot of cognitive load, a lot of things that's hard to manage, kind of like when I was in that Clojure script code base. Having to keep track of the state costs a lot of brain power. There is a paper in a talk called The History of Clojure that I will share that, I think this very well summarizes how Rich, why Rich set off to make Clojure, and its professional developers were encountering costly programming problems, coupling complexity, cognitive load, and information system headaches. And he had fallen in love with these functional programming principles, but he noticed none of them were actually used in production. So he wanted to change that. So at Nubank, we leverage, we really benefit from all of this thinking work that was done about the problems and how to solve them. And there are other solutions that we're not the only ones that are solving these problems, but we are one of the only ones solving them with simplicity at a production scale. So, fun thing is, this is kind of the solution section. So, I asked you to join me so we could explore how simplicity can make your software more powerful. Um, and simplicity matters because, we talked about this concept of reliability, that fewer moving parts means fewer failure points. We talked about how keeping your system simple makes you able to debug a lot easier because you have a clearer state and history. You have an audit trail. You can see what happened and when. You can observe your data at different points. Uh, it also matters because when we have all the simplicity, it enables us to be expressive and, powerful and honestly have fun with your programming. Remember when making programming fun again? And you have these abstractions that can scale because they're powerful. I mean, they're not reliant on anything else. They're not tied into anything else. They're not complected. And it's important because when you reduce all this cognitive load and you keep things simple, you are better able to reason semantically and you're able to have code that actually reflects the business logic. The reality, though, is the plot twist is mistakes still happen because we're human. Like Clojure and Datomic does not prevent humans from making errors at all. Humans make mistakes. That's like what we're really good at. However, what Clojure and Datomic does is it helps provide observability in audit trails, in authorization trails, in tooling that then empowers individuals and teams and the entire organization to investigate what went wrong and why and learn from it. They're able to learn from each other. Um, they're able to resolve issues really efficiently and quickly. When we have a crash, all it takes is somebody, 2 seconds, somebody on my team go in and figure out what it was and why and roll back because we have the audit trail, because we kept things simple. So by focusing on all of these, simplicity and leveraging these tools like Datomic and Clojure, that's how we're able to effectively manage the super complex domain of banking. And we're able to offer products that really, really help people in their lives. It's amazing that, that it's really hard for any individual to scale without resources, right? Nobody ever made it rich without borrowing some money. And so, we're able to give that success to people, and that's kind of cool. Um, and we've been able to ensure this reliability as the system has grown. We are able to offer the PIC system so people can send money to each other and help each other pay rent, help each other with groceries. And it's reliable because we're not losing people's money. That's really awesome. So, okay. This is the review section. Um, I started this talk with this story about how I over engineered my smart home by making things so complex that they stopped working for me. And we've seen how that same exact pattern plays out in software development, where having multiple systems depending on each other and being intertwined is complexity, and how that slows us down and how that creates all this unnecessary fragility and brittleness. And then it forces us to spend more time maintaining these systems than using them. And that is the definition of technical debt, is an increase in maintenance load that you cannot manage. And a lot of developers, that's one of the biggest problems I think most developers would say that they have. Um, so at Nubank, we've learned that it's not just a nice to have, it's a competitive advantage, and it's scaled us to over, I think we're one of the biggest banks outside of Asia now as far as customers. Um, we've gone from a startup to over 100 million customers, and we've done that by designing systems that are simple and easy to understand, extend, and maintain for both humans and systems at multiple levels of scale, at this organizational scale, this team scale, and on this individual level. Nubank has also leveraged the tool sets created by Cognitect, Clojure, and Datomic, and that's empowered us to keep things simple. I may have completely skipped over the part in the story earlier where in 2020, Nubank acquired Cognitect. And that's why I keep saying Nubank we. I think I skipped that. That's a really important part of the story. And something that I love that Nubank has done has been continue to sponsor open source developers. And that's actually happened to me. And it was really amazing to be recognized for my open source work. And my open source work was creating content like this. Um, so Nubank has used Clojure and Datomic to be very, very powerful. We do things like immutable data. We embrace immutable data. We use declarative queries in our database, and we really live these functional programming, data-oriented principles. And this allows us to focus on the business problems instead of wrestling with debugging all day. And that's one of the reasons we've been able to scale so quickly. We also really, another takeaway is problems are important and should be carefully, problem solving is a whole process, multi-level process, and it should be carefully framed before jumping to problems need to be carefully framed and thought out before jumping to implementing solutions. As we saw in Rich's philosophy, defining the real problem is the fastest way to get to a meaningful solution. But you really have to think about what the root cause, real problem is. And then the last kind of takeaway is simplicity benefits at every level of scale. This idea of, human, technology, and then organizational, team, and individual. When we reduce our dependency on each other, we're able to be more effective engineers. We're able to, operate with more autonomy, which feels nice for quality of life. We're able to collaborate better and enjoy our team. Like I love my team. And we're able to build robust systems that are resilient over time. Something that is about Clojure is that we don't do breaking changes. Your system will never break because of something the language changed, which is very rare. So, all right, as you leave here today, I encourage you to ask yourself, maybe where is complexity creeping into your work? Where are those dependencies happening? Are there anything that are becoming crossed and you can't think of one thing without thinking about the other? Are there layers that you're able to remove? And if you're not able to remove those layers, you have some complexity, buddy. And then, consider what would a simpler version of your system look like? Are you able to deprecate things? Are you able to peel back layers? And just envision. If you're curious, so kind of in closing, at Nubank, we believe that the best systems aren't the ones with the most features or the most layers of abstraction, although we do have features. But we want systems that are clear, predictable, powerful, focused, and simple. They get that way by being simple. And we embrace that at every level of our work. So here's some shameless self-promotion here. My moniker online is Lambda, like Lambda calculus, because functional programming, because nerd stuff. This is a QR code that goes to my link tree because I have so many projects. It's ridiculous. And actually, I just had I co-authored a book with Alex Miller, who is on the Clojure core team. And that actually came out. It is now out of beta. It is an alpha, and it comes out in print on April 1st. So that's cool. It'll be the first time, I'm a published author, mom. Um, and Clojure Brain Teasers is 30 short exercises. Each exercise is simple, as in it is designed to um, help you learn something about the language design and why it works that way. Um, if you are seeing this and you want to learn more about Clojure and Datomic, I also co-founded a nonprofit mentorship learning group. It's really just a Discord. And soon we're going to be kicking off Datomic and Datalog mob programming sessions, where once a week we meet up. I pick a little challenge, and then we all log into the same server, so you don't have to have any tooling set up on your machine. You just show up, and we have show up, go to a link. We're all logged into the same machine, and then we all alternate 5 minutes each person coding up a solution and communicating about it. It's a really fun, awesome way to learn and improve your mental models. Um, and then watch out for kind of upcoming talks I'll be giving in DC coming up soon at a reliability conference, at Reclojure in London in May, and then at Lambda Days in Poland in June. Here are some resources that I used to kind of that I referenced during this session. I highly recommend this talk, The Exploring Force and Superpowers of Datomic, if you want to get more technical about why Nubank chose Datomic and what they use. All those problem statements came from effective programs. Most of this stuff came from Simple Made Easy. And then architecting a modern financial institution was something that Edward also did. And that is a very nitty gritty, highly technical architecture discussion on how Nubank is built. And I'll leave you with my favorite meme I made and say thank you